Close your eyes for just a second and imagine this. Somewhere, far beyond the stars you can see, an intelligent civilization is doing exactly what we are doing right now, asking questions, building ideas, and wondering if they are alone. Now open your eyes and ask yourself something deeper. If they exist, why haven't they reached us? Why hasn't even a single undeniable visitor crossed that cosmic ocean to knock on our door? Tonight, we are not going to chase science fiction. We are not going to rely on guesses, conspiracies, or wishful thinking. Instead, we are going to do something far more powerful. We are going to listen to the universe itself, because the universe has rules, and those rules are not flexible, not negotiable, and definitely not impressed by advanced technology or alien intelligence. What you're about to hear may challenge what you've always believed. It may even feel counterintuitive at first. Because the truth is not that aliens don't exist. The real question is whether the universe even allows them to reach us at all. And once you begin to see the hidden barriers, speed, distance, energy, time, you'll realize something astonishing. The silence of space might not be a mystery. It might be inevitable. So stay with me, because by the end of this journey, you won't just be thinking about aliens differently. You'll be thinking about the universe itself in a way you never have before. Imagine for a moment that somewhere out there, across the silent ocean of space, an intelligent civilization looks up at its sky just as we do, wondering if they are alone, building machines, dreaming of distant worlds, perhaps even dreaming of us. It's a beautiful idea, almost irresistible. But when we stop daydreaming and start asking nature how things actually work, we run into a stubborn, almost frustrating truth. The universe is not built for easy travel. It is vast, strict, and governed by rules that don't bend just because we wish they would. The first and most unforgiving of those rules is the speed limit of the universe. Light travels at about 300,000 kilometers per second, and that sounds incredibly fast, and it is. You could circle the Earth 7 times in a single second at that speed. But here's the catch. According to everything we understand about physics, nothing with mass can reach that speed, let alone exceed it. The closer you try to get to it, the harder it becomes. It's not just a bit harder. The energy required increases dramatically, approaching infinity as you approach the speed of light. So even the most advanced alien engineers, no matter how clever, would run into the same wall. It's not a technological limitation. It's baked into the structure of reality itself. You don't solve it with better engines. You would have to rewrite the laws of physics. Now suppose you accept that limit and decide to travel slower than light. That brings us to the second problem, which is distance. Space is not just big. It is absurdly big in a way that our brains are not naturally equipped to grasp. The nearest star system, Proxima Centauri, is over 4 light-years away. That means even light, the fastest thing in existence, takes more than 4 years to get there. If you built a spacecraft that could travel at, say, 1/10 the speed of light, a staggering achievement far beyond anything we can currently do, it would still take over 40 years just to reach the nearest star. And that's the nearest one. Most of the planets we think might support life are tens, hundreds, or thousands of light-years away. At that same speed, you're talking about journeys that last centuries or millennia, not a mission, not a voyage, a commitment across generations. And that leads naturally into the third issue, energy. Moving something through space is not free. The faster you want to go, the more energy you need, and the relationship is not linear. It grows steeply. To accelerate even a modest-sized spacecraft to a significant fraction of the speed of light would require an amount of energy comparable to what entire civilizations produce over long periods. Imagine taking all the energy generated by a planet, every power plant, every star harvesting idea you can imagine, and pouring it into pushing a single ship. And that's just for acceleration. You'd also need energy to slow down when you arrive. Otherwise, you'd just zip past your destination. When you start adding it all up, interstellar travel stops looking like an engineering challenge and starts looking like an energy problem so enormous that it borders on the impractical. But perhaps you think, what if the travelers themselves don't experience all that time? This is where relativity introduces a subtle twist. As an object moves faster, time for that object slows down relative to someone at rest. So from the perspective of the travelers, a long journey could feel much shorter. This is not science fiction. It has been experimentally confirmed. Clocks on fast-moving particles really do tick more slowly. But here's the important part that often gets overlooked. This doesn't make the journey shorter for everyone else. From the perspective of the origin and destination, the trip still takes decades, centuries, or longer. If aliens set out for Earth from hundreds of light years away, even if their onboard clocks make it feel like a brief adventure, Earth itself would still be waiting for a very long time. Civilizations could rise and fall in the meantime. The universe does not synchronize its clocks for your convenience. Even if you somehow solve the issues of speed, distance, and energy, space itself is not empty in the way people often imagine. It's not a perfect vacuum. There are atoms, dust grains, and tiny particles scattered throughout it. At everyday speeds, these are harmless. But at relativistic speeds, approaching the speed of light, they become dangerous. A tiny speck of dust, something you wouldn't even notice on Earth, turns into a high-energy projectile. The energy released in a collision depends on velocity, and at those extreme speeds, even microscopic particles can deliver impacts equivalent to explosions. A spacecraft traveling through interstellar space at such velocities would be constantly bombarded by these invisible bullets. Shielding against this is not trivial. You're not just building a ship, you're building something that has to survive a continuous stream of high-energy impacts for years or decades without failure. One weak point, one failure in shielding, and the consequences could be catastrophic. Then there is the question of survival, not just of the spacecraft, but of the beings inside it, or the systems meant to carry their consciousness or biology. If a journey takes hundreds or thousands of years, who or what makes the trip? Biological organisms have limited lifespans. Even if you imagine advanced medical technologies, indefinite survival is not something we know how to achieve, and it may not even be possible. So you might think of generational ships, where multiple generations live and die during the journey. But that introduces social, psychological, and logistical complexities. How do you maintain a stable society in a closed environment for centuries? How do you ensure that the descendants of the original crew remain committed to a mission they did not choose? Alternatively, you might imagine machines, autonomous probes, or artificial intelligences. But then you run into another issue: long-term reliability. Even our best machines degrade over time. Components fail, materials fatigue, radiation accumulates damage. Keeping a system operational over such enormous timescales is a challenge we have not solved. It's not just about building something that works. It's about building something that continues to work without maintenance for longer than human history has even recorded. And underlying all of this is a deeper point that is easy to miss when we focus on individual obstacles. Each of these problems, speed limits, distance, energy, hazards, longevity, is not isolated. They stack on top of each other. Solving one does not eliminate the others. If you somehow find a way to get close to the speed of light, you still have to deal with energy requirements and particle collisions. If you design a system to last for centuries, you still have to confront the immense distances involved. The universe is not presenting a single locked door. It is presenting a whole series of them, each requiring a different key, and some of those keys may not exist at all. So when people say it is physically impossible for aliens to ever reach Earth, what they often mean is not that there is a single equation that forbids it outright, but that the combined weight of these constraints makes it so extraordinarily difficult that it becomes effectively impossible in practice. It's like asking whether you can jump across an ocean. There is no single law that says you cannot leave the ground. But when you consider the distance, the energy your body can produce, the need to survive the journey, and the lack of anything to stand on in between, the answer becomes clear. And yet, there is something fascinating hidden in this conclusion. The same laws that make it nearly impossible for others to reach us also make it nearly impossible for us to reach them. The universe is not just big, it is isolating. It creates islands of stars, separated by distances that are incredibly difficult to cross. This doesn't mean that life doesn't exist elsewhere. In fact, given the number of stars and planets, it would be surprising if it didn't. But it does mean that even if intelligent life is out there, it may remain forever out of reach, not because of a lack of curiosity or intelligence, but because of the fundamental structure of the cosmos. So the real lesson here is not about aliens failing to visit us. It's about understanding the universe on its own terms. Nature is not obligated to make things easy or convenient. It follows its own rules, and those rules shape what is possible and what is not. When we look up at the stars, We are not just seeing distant lights, we are seeing the boundaries of what we can physically touch. And in that sense, the silence of the cosmos may not be a mystery waiting to be solved, but a consequence of the very laws that allow the universe to exist in the first place. So as we reach the end of this journey, we arrive at a realization that is both humbling and strangely beautiful. The universe is not silent because it is empty, and it is not distant because it lacks life. It is silent and distant because it is governed by laws that are deeper, stricter, and more uncompromising than our imagination ever expected. The same rules that light the stars, shape galaxies, and hold atoms together are the very rules that build invisible walls between civilizations. What once felt like a mystery, where is everyone, begins to transform into a different kind of understanding. Maybe it's not that no one is out there. Maybe it's that the universe has designed distance, time, and energy in such a way that meeting each other is not just difficult, but nearly impossible. And in that realization, something shifts. Instead of feeling small, we begin to see how rare and precious our own existence is. Out of all this vastness, all this separation, here we are, aware, curious, asking questions, trying to understand it all. And perhaps that is the real message hidden in the silence of space. Not loneliness, but responsibility. If we are isolated, then what we do here matters even more. Every discovery, every idea, every step forward becomes part of something incredibly meaningful. We are not just observers of the universe. We are one of the few places where the universe gets to understand itself. So don't walk away from this thinking the cosmos is cold or unreachable. Walk away realizing that you are part of something extraordinary, something rare, something that exists against incredible odds. And maybe the goal was never to reach the stars, but to understand them, to learn from them, and to let that knowledge transform the way we see ourselves. Thank you for staying curious, for staying engaged, and for taking this journey all the way to the end. I truly wish you the best in your own exploration of ideas and knowledge. Keep questioning, keep learning, and good luck on every path you choose ahead.